Okay, so I'm not sure where we left off, but I'm going to just start through 7 and do the rest of them. So this is page 271 in your journal. If you've already done this problem, just have the step skip ahead. I know in some of my classes we've done it, but not in all of them. So I need a pen. Okay. So we need to solve this triangle, so that means that we need to find all the missing sides and all the missing angles. So I see that right here we're missing this side, AC, so we have to find it. I'm going to call it X, and then we also are missing angle A and angle C, so we have to find those as well. So if you look at your steps, let's find the missing side first. So the first thing it says is, can you use the Pythagorean theorem to solve this? And the answer is yes, because I'm given these two sides. If I have two sides, I can find the third side using the Pythagorean theorem. And in fact, I can't use trig since I don't have an angle, so I have to use the Pythagorean theorem. Now remember, the Pythagorean theorem is leg squared plus leg squared equals the hypotenuse squared. And the legs are 6. So we have to find the hypotenuse. So the hypotenuse is across from the right angle. So in this case, it's X. So remember, the hypotenuse has to go here. And then our legs are 6 and 12. So we're going to do 6 squared and 12 squared. And I get 36, and 12 squared is 144. And that equals X squared. Then I'm going to add 36 and 144. I need to get my calculator for that. Hold on, I'm going to pause while I get my calculator. Okay, so I'm all set. 36 plus 144 is 180. And that equals X squared. And then I have to take the square root of both sides. And it turns out that the square root of 180 is 13.4, and we're rounding to the nearest tenth. So 13.4. And I put this over here, and then remember, the hypotenuse should be the longest side, and it is. It's definitely longer than 6 and 12, so that's good. Also, it has to be smaller than 6 and 12 added together, so 6 plus 12 is 18. It is smaller than 18. So this looks like a good answer. Okay. Let me grab another color. So now I'm going to find angle A. So to find angle A, I have to identify the opposite and adjacent sides. So if I have my marker here and I cover that up, this tells me that this is the opposite side. So 12 is the opposite and 6 is the adjacent. So to find angle A, I'm going to say I have to use the two sides they gave me. So the two sides they gave me were 6 and 12. So I have to use 6 and 12. Now you'll notice that 12 is the opposite and 6 is the adjacent. So that tells me I'm going to use O and A. And remember, SOHCAHTOA is SOHCAHTOA. And I'm writing that way up here at the top. Okay, so which trig function uses O and A? And we should be on the angle side to find a missing angle side of our little note card, our note sheets. And it's tangent. So I'm going to use this formula. The angle equals the inverse tangent of the opposite over adjacent. So remember, when you're finding an angle, you use the inverse buttons. So my angle, which is angle A, is going to equal the inverse tangent of my opposite, which is 12, and my adjacent, which is 6. So I get angle A equals, now remember, you have to put your calculator in degree mode. And you're going to find the inverse tangent of 12 over 6. So I'm going to say second, and then tangent, which will give me the tangent inverse, and then I'm going to say 12 divided by 6. And I get 63.4. So A is 63.4. Okay, now I'm going to use a similar method to find angle C. Now I can just add them up and subtract from 180, but I'm going to go ahead and use trig, and then I'll add them up and make sure they do all add up to 180. So that's how I'm going to double check my work here. So right here's my work for angle B, or sorry, angle C. So I'm now here at angle C, and that means my opposite and adjacent have to change. So now this is the opposite, and this is the adjacent. And I still have to use 6 and 12. This time 6 is the opposite, and 12 is the adjacent, so that's still O and A. So I'm going to say the angle is equal to the inverse tangent of the opposite over the adjacent. So that means angle C is equal to the inverse tangent, this time of 6 over 12, not 12 over 6. So on my calculator, I'm going to say inverse tangent, so second 10, but this time 6 divided by 12. And I'm going to get 26.56. But that last 6 makes a 5 a 6, so it's 26.6. And then I'm just going to add them up and make sure I get 90. So if I add 63.4, I'm sorry, and get 180, and 26.6, and 90, I should get 180. So let me just double check that. 90 plus 63.4 plus 26.6, then I get 180. So that's my check, it works. So that did equal 180. Okay, so my answers were 26.6 for angle C, and 63.4 for angle A, and 13.4 for that missing side AC. Okay, number 11. Again, same thing, but this time we're finding any missing sides and missing angles. So again, we have a missing side here. Let's call it X, ED. And then we need to find the missing side C, or the missing angles C and D. So once again, we have two sides of the triangle given. So we can use the Pythagorean theorem to find the missing side. So remember, that's leg squared plus leg squared equals the hypotenuse squared. In this case, the hypotenuse is across from the right angle, and that's 75. And then my two legs are x and 21. So I get x squared plus 441, and then 75 squared is 5625. Okay, but I wrote that wrong. It's 5625. So I'm going to subtract 441 from both sides, and I get x squared equals 5184, and then I have to take the square root of both sides. So the square root of 5184, and I get 72, so x is 72, so my missing side is 72. Now my missing side is not the hypotenuse. My hypotenuse is 75, which is the longest side, so that's good. And then 21 plus 72 is definitely bigger than 75. So this answer seems like it's appropriate. Okay, let's find angle C. So I need another color. Let me get red. Here's C. And this side would be the opposite. and that would force this to be the adjacent. Okay, now I have to use the two sides that they gave us. So they gave us 21 and 75. So to find angle C, I have to use 21 and 75. So 21 is the adjacent and 75 is the hypotenuse. I didn't write that that was the hypotenuse, but it is. Okay. So let me write my trig function up here. Here we go, SOHCAHTOA. Which one uses adjacent and hypotenuse? And if you're saying to me right now, cosine, you'd be right. But we're finding an angle again, so remember we're using inverse cosine. So we're going to say the angle equals the inverse cosine of the adjacent over the hypotenuse. And then again we're going to say the angle equals the inverse cosine of the adjacent, which is 21, over the hypotenuse, which is 75. And then I'm going to plug that into my calculator. So inverse cosine, so second cosine, and then 21 divided by 75. And I get 73.7. Okay, so I know that this angle right here is 73.7. And then I need to find angle D. So since I'm finding angle D, I'm going to put a dot here. And now this is the opposite. And 72, or this x, is the adjacent. Now I still have to use the 21 and the 75. So in this case, for finding angle D, I have to use 21, which is the opposite, and 75, which is the hypotenuse. So that tells me I'm going to use O and H, which is sine. And again, it's an angle, so I'm going to say the angle equals the inverse sine of the opposite over the hypotenuse. So my angle equals the inverse sine of 21 over 75. So on my calculator, I'm going to do second sine, and then 21 divided by 75. And you get 16.3. It's 16.26 actually, but the 6 makes the 2 a 3. So 16.3. And then I'm going to add the 73.7 and the 16.3 and the 90 to make sure I get 180. I'm not going to write it down, I'm just going to do it. Plus 90, and I get 180. So good, it's working. Okay, let's do number 9. So number 9 is another triangle we have to solve. So this time it looks like we're missing two sides. So I'll call that one X and this one Y, and an angle. So to find the missing angle, we just use the triangle angle sum theorem, which means all the angles of a triangle have to add up to 180, right? So I'm going to add them, 90 and 52. And I get 142. Let me just double check. 90 and 52 is 142, and then I'm going to subtract that from 180, and I should get 38. So 180 minus 142 is 38. So this angle is 38. Okay, so we found angle N. Angle N was 38. Okay, now to find the two missing sides, I cannot use the Pythagorean theorem because I'm missing two sides. So let's start with X. So let me get a new color. Let me write SOHCAHTOA up here. So so I have to use trig because I only have one side. And since my hypotenuse is 3, it looks like x and y have to be definitely smaller than 3. So we're going to be getting some fairly small numbers here. Okay. So we're starting with x. So to find x, I need to put my angle, or dot on the angle that I know. And that's the 52, and the side across from that would be this side over here, y. So that's the opposite. And to find the hypotenuse, I draw a line through the right angle, and then that makes x the adjacent. So to find the adjacent, or to find x, I have to use x. Since I'm finding it, I have to use it. So that's a, the adjacent side, and I have to use the side they give me. They only give me one side, 3. That's a hypotenuse, so I have to use it too. So if I look up here, it looks like a and h is cosine. Now this time I'm finding a side, not an angle, so I'm using the first side of the paper, and I say this: the cosine of the angle equals the adjacent over the hypotenuse. So my angle is 52, so I'm going to plug that in. The cosine of 52 equals the adjacent, which is x, over the hypotenuse, which is 3. I'm going to put this over 1 and cross multiply. So 1 times x gives me x, and then here I do 3 times cosine 52. And then again, I'm not using the inverse button because I'm finding an angle, so I'm just going to use the regular one. And I multiply 3 times the cosine of 52 out, and I get 1.8. So this is 1.8, and that's definitely less than 3, so that's looking like it's a promising answer. Okay, now let me get another color. Sorry. Oh my goodness. Okay, since I'm not moving angles, I'm still using the angle they gave me, 52. I don't have to relabel. But this time to find y, I have to use y, and y is the opposite, and I still have to use the 3 which they gave me, which is the hypotenuse. So opposite and hypotenuse is sine. So I'm going to say the sine of the angle equals the opposite, over the hypotenuse. So the sine of my angle is 52, and that's equal to the opposite, which is y, over the hypotenuse, which is 3. And then I cross multiply, and 1 times y is y, and this is messy, but this is a 3, and then 3 sine 52. So plugging that into my calculator, I get 3 sine 52 and again, not the inverse, the regular button, and I get 2.36, so that would be 2.4. Okay, so y is 2.4, which is smaller than 3. And when I add 1.8 and 2.4 together, I get a number bigger than 3, so these numbers look reasonable to me. Okay, now number 10. Again, another right triangle to solve. This time I have an angle. I have 2 angles, and I'm again finding 2 sides. So I'm going to use the triangle angle sum to find the missing angle. So I'm going to do 90 and 29. So 90 and 29 is 119, and then 180 minus 119 is 61. So this angle is 61. So angle y is 61. And then I need to find these sides. So let's call this side A, and this one B. I don't want to use X and Y because of X and Y right there. All right, so to find A, again, SOHCAHTOA. Okay, so to find angle A, I'm going to do not angle A, this is side A. To find A, little a, I guess, I need to label. So here's the angle they gave me. The side across from that is right here, so that's the opposite. And then from the right angle, I get the hypotenuse. So this must be the adjacent. So to find A, I have to use A, which is the adjacent. And I have to use what they gave me, which in this case is 18, which is the opposite. So opposite and adjacent is tangent. Love you too. Okay, so adjacent over opposite is tangent. So I'm going to say the angle equals the tangent of the opposite over the adjacent. So in this case, my angle, oh, I wrote this way wrong. All right, sorry. It's the tangent of the angle equals opposite over adjacent. I was looking at it and it looked very funny to me. Okay, the tangent of the angle equals opposite over adjacent. So the tangent of my angle, which is 29, equals the opposite, which is 18, over the adjacent, which is A. I'm going to cross multiply, and I get 1 times 18 is 18, and this way I get A tangent 29. Now notice A is not by itself, so I have to divide both sides by tangent 29. And I get 18 divided by tangent 29. Tangent 29, and I get 32.5. So this side is 32.5. Okay, gosh, I kind of boxed myself in. Okay, let me find B now. So to find B, I don't have to relabel, but this time I need to find B, and B is the hypotenuse, so I have to use hypotenuse, and I have to use what they gave me, which is the 18, which is opposite. So that's going to be sine. So I'm going to say the sine of the angle is equal to the opposite over the hypotenuse. So the sine of the angle, this time my angle is still 29, and my opposite is 18, and my hypotenuse is B. So put this over 1 and cross multiply, and I get 18 equals, and then B times sine 29 is B sine 29. So again, B is not by itself, so I have to divide both sides by the sine of 29. So I get B is 18 divided by the sine of 29. So 18 divided by sine 29, and I get 37.1. Okay, and this is my hypotenuse, so it should be the biggest side, and it's bigger than 18 and 32.5, so that's good. And it's not too big because it's smaller than 18 plus 32.5. Okay, now my favorite word problem. So this is on page 271. So that's still the same page we've been on. And it looks like we have a boat, which is being pulled in by a winch on a dock that's 12 feet above the deck of the boat. So this vertical distance right here is 12 feet. When the winch is fully extended to 25 feet, this is 25 feet, what is the angle of elevation from the boat to the winch? So now remember, the angle of elevation is the angle looking up. So that's this angle right here. So that's what I'm looking for. I want to find that angle. So let's call it angle A. Okay, so I'm looking for an angle. So to find an angle, first you see if you can use a triangle sum. And you can't. We're really not given any angles, but I know that this is a right angle there because it makes a vertical line with the water. The side of the dock and the water are perpendicular. So we're going to make a right angle there. And then I only have that this is a right triangle. I don't have the angles. So I have to find this missing angle. So to find a missing angle, I have to identify what's opposite, what's adjacent, and what's hypotenuse. So this side is the opposite, and the side across from the hypotenuse is the hypotenuse. So I'm using, and then this would be the adjacent. So I'm finding the angle, and I have to use the two sides they gave me, which were the 12, which is the opposite, and the hypotenuse, which is 25. And remember, SOHCAHTOA is SOHCAHTOA. So to find this angle of elevation here, I'm going to say sine, because O and H is sine, but I'm finding an angle, so the angle is the inverse sine. I have to use inverse opposite over hypotenuse. So my angle is equal to the inverse sine of opposite, which is 12, over the hypotenuse, which is 25. So when I plug that in, okay, hold on, having trouble opening my phone to use my calculator. Okay, so I'm doing the inverse sine. So again, second sine, and then 12 over 25. And I get 28.7. Okay. And so that's it. The angle is 28.7. Okay, so number 9, this is back on page 261. So go back to page 261, and we're doing problem number 9 here. So we have a boy that flies a kite at an angle of elevation of 18 degrees. Okay, so the boy's got a kite. So here's boy, and he's got a kite in his hand. So there's a string for the kite, and here's the kite. Okay, and the angle of elevation from his hand to the kite is 18 degrees. Okay, and the kite reaches its maximum height, so this is its maximum height, 300 feet away from the boy. So this distance right here is 300 feet. Okay, and we want to know how high the kite is, so that would be this distance right here. Okay, now we're not going to worry he's holding it, and we don't know how tall the boy is, so we don't know how we don't know how high his hand is off the ground, but we're not going to worry about that in this particular case. If it gave us information about that, we would use it, but it doesn't, so we're not going to worry. Okay, so we can pretend he maybe stuck it into the ground at some point, so it's flying from the ground. Okay, so I have to decide what trig function I'm going to use. I need to find a missing side. I don't have two sides, so I can't use the Pythagorean theorem, so I have to use trig. So I'm given this angle 18, and this side would be the opposite, and here's my right angle, so that would be the hypotenuse, and this is the adjacent. So I'm finding x So I have to use x, so that's the opposite, and I have to use the side they gave me, which is 300, and that's the adjacent. So that tells me I'm using tangent, because SOHCAHTOA, opposite and adjacent, is tangent. So I'm going to say the tangent of the angle is equal to the opposite over the adjacent. So the tangent of my angle is 18, and that's equal to the opposite over the adjacent. Put it over 1, cross multiply, and I get x is 300 times the tangent of 18. So this time x is by itself, so I just go ahead and multiply. So it's 300 times the tangent of 18. And I get 97.5. Yep, 97.5. Okay, so we know the kite is about 97.5 feet off of the ground. Okay? All right, number 10. This is on page 266. And this one says a camera is attached to a kite. So we got a kite in the ground, or sorry, in the sky. We've got a little camera attached to it. That dot right there is the camera. Okay? And it's filming the damage caused by a brush fire in a closed off area. The camera is directly above the center of the closed off area. So this is right here, the direct center of this closed off area. The closed off area might be circular, it doesn't really say, right? And there's a person standing 100 feet away from the center of the closed off area. So right over here we have a person standing 100 feet away. Okay. And we know that the angle of depression from the camera to the person flying the kite is 25 degrees. So the camera's line of sight is this line right here. Okay, but if it's going to be looking down at the person, that would be that. So this angle right here is the angle of depression, and we know it's 25. Okay, the problem is we need to find we need to use this triangle right here to find the height. So it turns out that this angle right here, the angle of depression, is equal to the angle of elevation right here. So that's also 25. Okay, and we know that this is 100. And what we're asking is how long is the string of that kite. So that's x right there. Okay. All right. So here we go. I have to use this angle, and the side across from that is this side right here, so that's the opposite. And here's the right angle, so this is the hypotenuse, and this is the adjacent. And I'm running out of some room, so I think I'm going to go over here, get another color. And maybe I can do it, I can probably squeeze it right in here. Alright, so I'm looking for, there's more room over here. I think I'll do it over here. So SOHCAHTOA. And I'm looking to find x. So x is the hypotenuse, so I have to use that. And I have to use 100, which is what they gave me. That's the adjacent. And that is cosine. Hypotenuse and adjacent is cosine. So the cosine of the angle is equal to the hypotenuse. Oh no, it's the adjacent over the hypotenuse. Okay, whoops. So adjacent over hyp. So the cosine of 25 is equal to 100 over x. Put that over 1, cross multiply, and I get 100 equals x, and I'm going to have to go over here because I'm running out of room. 100 equals x cosine 25. So I'm going to divide both sides by cosine 25. Sorry, this is page 266. So 100 divided by cosine 25. And I get 110.3. So x is 110.3. So the string of the kite is 110.3 feet away. All right, and then for B here, part B, is if the string on the kite is 200 feet long, so let's redraw the picture. Here's the kite and the camera. This time I'm saying the string of the kite is 200 feet long. And this is the center of the damaged area. How far away is a person standing if it's 200 feet long? So this is interesting. Let me just go back a little bit. Here we found out that it was 110.3 feet long, right? So for the string to get longer, never mind. So now we need to know how far away he's standing, right? Okay. So in that particular case, we're looking for that angle right there, or that right there. And again, we still have the same angle of depression, which was 25. So this is still 25, right? So this is the opposite. We're looking for this distance right here, x. Let me get rid of that. Okay. So this is still the opposite, and this is the hypotenuse. And this time we're finding x, which is the adjacent. So we're finding adjacent, and we have to use the hypotenuse, so that's cosine. So the cosine of the angle is equal to the adjacent over the hypotenuse. Oh, I forgot to write the formula. So adjacent over hypotenuse. So the cosine of 25 is equal to x over 200. So cross multiplying, I get x equals 200 cosine 25. So I'm going to plug that into my calculator, and that will be my answer. So 200 cosine 25 and I get 181.3. So he's standing 181.3 feet away. Okay? All right, good.